Homework number 6, question number 1A. For this question, we have a truss. First, you have to determine what degree of indeterminate. So we have members. So you have 1, 2, 3, 4, 5. Oh wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 plus reactions. You have 1, 2, 3 reactions. And joins 1, 2, 3, 4, 5, 6. So minus 2 times 6. So 13 minus 12. So first degree. So we're gonna have first degree determinacy. So we can use the old way to find it. So we have to use matrix. So first you have to set up the table for matrix. So we have point A, B, C, D, E, F, A, B, C, D, E, F. And we have X and Y axis. So start with AB. So we have to write down the members. So we have AB. You're going to have BC. You're going to have CD. And we're going to have let me see what's the next one. AF. DE. AF and DE and EF. You're gonna have FB. You're going to have EC. You're going to have BE. Oh yeah, I forgot something. Because this is first degree determinacy, indeterminate. So we have to choose one members as your redundants. But if you read questions, if you have the questions, you see the second one is the same as the first one. So if you choose FC as your redundants, you don't have to redo the matrix again for the second one. So let's choose FC as your redundants. So for the second one, you use the same matrix. It's easier. So we choose this as your redundants. You erase this and you put 0. Because you remove it, so of course the false is going to be 0. So you have that. So you're going to have BE. You're going to have AY. You're going to have AX. You're going to have DY. So right here, you also put it as AX. AY and DY. So now let's put in the ratio of the matrix. Here is 20, 20, 20, and the height is 15 and 15. So the incline, if you do the A squared plus B squared equals C squared, this one is going to be 25. Here's 20, here's 25, 25. So for point A, AB is going to be 1 because it's only going to the horizontal. Vertical is 0. For point A, there's no A letters, so it's 0, 0. 0, 0, AF. AF is here to here, so I assume going this way is positive, negative, negative, positive. So if AF is going that way, when you convert to the X and Y component, it's going to be positive and positive. So you're going to write positive, positive. And the ratio is, you want to convert AF to X, so it's this and this. You know the ratio is always some number over some number. This is always your largest number, which is 25. It never changes for ratio. So if you want to look at the x, you see 20, so it's 20 over 25. You want to find the y component, it's 15 over 25. That makes it easier. So for x, it's going to be 20 over 25, and here is 15 over 25. Yes. And no 8, so it's 0, 0. Ax. Ax in the x-axis, we have 1. But in the y-axis, we have nothing. Ay same thing. In the x-axis, we have nothing. But in the y-axis, we have 1. So 0, 0. For point B, right here, AB, we're going backward. It's here to here, so it's negative. So we have negative 1, 0. BC. BC is here to here, so it's positive. So we're going to have 1 and 0. CD have no B in there, so 0, 0. FB. FB is vertical, and it's from point B to point F, so it's going up. So it's going to be in the x-axis, nothing. In the y, we have 1. No B. BE. B is going this way, so when you have convert this into x and y, it's going to be positive and positive. So you put positive and positive. And like I said before, the largest number is always at the bottom, so it's going to be 25. You want x, it's 20 over 25. You want y, it's 15 over 25. So it's going to be 20 over 25, 15 over 25. Point B had nothing to do with 8, so 0, 0. Point C, right here. AB had nothing to do with that, so it's 0. BC, BC, so it's going backward from C to B, so it's negative 1, 0. CD, CD, so it's 1, 0. No D, no C, 0, so no C. EC. EC is going up, so C to E, so it's going up, so it's positive. That means Y is 1. BE. BE had nothing to do with C, so 0, 0. For point D, right here, so AB had nothing to do with D, so 0. CD, going backward, D to C, so it's negative. AF, nothing. DE, DE, this one. When you convert incline into X and Y, Y is going to be positive and X is going to be negative. So X is going to be negative and Y is going to be positive. So like I said before, the largest one is your bottom number. So you want to find X is 20 over 25, Y is 15 over 25. So X 20 over 25 and Y is going to be 15 over 25. D have nothing to do with FE, so 0, 0, 0, 0. Nothing. DY. In the x-axis, have nothing, and in the y-axis, we have dy, so we have 1. So point E now, point E is right here. E have nothing to do with AB, so 0, 0. DE is going backward. Incline is going this way. So when you convert this into x and y, x is going to be positive and y is going to be negative. So x is positive, y is going to be negative. So for x is 20 over 25 and y is 15 over 25. EF, EF, EF going this way, so it's negative. Negative 1, 0. E had nothing to do with this. EC. E to C is going down. so it's negative in the y-axis. BE, E to B, going this way. So when you convert this into this, x and y, x is going to be negative, y is going to be negative. So negative, negative. And for x is 20 over 25. And y is 15 over 25. AX had nothing to do with this, so all 0. And the last one, point F. Point F had nothing to do with AB, so 0. AF. F to A, so going this way. So when you convert this into x and y, x is negative, y is negative. So negative, negative. For x is 20 over 25. And for y is 15 over 25. FE. F to E. So going this way. So it's positive. So 1, 0. Wait. Oh, DE, I'm sorry. 0, 0. EF. Yes. Negative 1. I'm sorry. Positive 1. 0. And FB. F to B going down. So it's negative in the y-axis and 0 in the x-axis. EC had nothing to do with F, so 0, 0. So this is our matrix. So you want to find this member over here. Because we make this as your redundance, you remove this. After that, you have to find all the force for internal force for each members. That's why we're doing the matrix. Now we have the matrix. We want to find the force for each member. So you're going to have the second columns. And you put down all the members like this. So you're going to have AB, BC, CD, AF, DE, EF, FB, EC, BE, AX, AY, and DY. Is equal to this column. This column is the point load or force, if one call it force. So you look at the table, not table, the stress. You're gonna have 1, 2, 3 point load. So for this one, it's at point B. But when you do the matrix, you're gonna flip it. So if you see negative, because going down is negative. So if you see negative, you have to flip it, become positive. So at point B, in the y direction, point B in the y direction, you're going to have, going down is negative, so you have to flip it, become positive 20. And in point C, the y direction, same thing. You have negative going down, so you're going to have positive 25. And the last one is at point E in the x-axis. Point E in the x-axis. So you're going to have, going this way is positive. Like I said, if you see positive, you have to flip it, become negative. So negative 28, and the rest is 0. So now you have the whole matrix. Let's call this whole matrix A, and this little thing over here, call it B. So to find all the force, you have to go to, you know how to use calculator, I don't need to explain. You take A, -1, times B. So you're going to have a list of numbers, and that is your internal force for the members. So if you do that, you're gonna have, that's right. Can you see from this part over here? No? So I'm gonna write right here.
You only have one board right here.
You're gonna have you're gonna have 47.56, 40.44, negative 24.44, negative 50.56, negative 19.55, 14.67, 25, 8.89, and you're going to get a 8x, which is, damn, if I even write it down, but give me a minute.
Should I pause it?
No, I have the matrix, so let me just do it quick.
How long it should be? Doesn't matter. As long as
Yeah, I thought just stop it for a while. So so for the next one is AX. So AX is 28, or negative 28, so it's going that way. And for AY is 14.67, for this one is 30.33. This is the internal force for the trusses, for the truss. So next one, because you make it as your redundance. Next one, you're going to use the unit load. So you're going to have another matrix. So you put this. Because you remove this one. If you remove it, you're going to put a unit load, one right here. And you remove all the force. A, B, C, D, E, F. So now you're going to do another matrix for this one. Like this one and this one, nothing changed. All the dimensions is the same thing. So this big matrix is not going to change. All is changed is only this columns. So let's change this one. So you have one here, but you know, oh yeah, when you make a cut, you always assume the arrows going out, which means it's tension. So when you get the number is negative, is compression, positive is tension. So if this is 1, this force is 1 and this force is 1. So you can convert it into the x-axis and y-axis. Same thing like this one, x-axis and y-axis. 1 for this one, this is 20, this is 15, and this is 25. So for this one, it's going to be 0.8, 0.6, because when you see the triangle like this, if this is 3, 4, 5, and same as 6, 8, 10. So in this case, you have 1 here. That means this is 1. If this is 1, this is 0.6, and this is 0.8. So you know this is 0.8, this is 0.6. And same thing here, 0.6 and 0.8. So let me erase this, it's not going to confuse you. So, like I said before, because all the length and the matrix didn't change for the big one, all it changed is this one. So right now, we only have 4 fours, which is 0.6, 0.8, 0.6, and 0.8. And it's all located at point F and point C. Because when you move this back here, every force is at point C and F. So let's do C first. So for C, you remember before we had this? Positive, positive, negative, negative. So this 6 is going that way, so it's negative, and this one is going up, is positive. But like I said before, if it's going to negative, you change it to positive. Going to positive, you change to negative. So for C, in the x-axis, we're going to have positive point C. In the x-axis, let's erase the old numbers. Point C, the x-axis, we're going to have, going that way is negative, so we're going to have 0.6 positive. In the y-axis, we're going to have going up, so it's going to be negative. So it's negative 0.8. At point F, right here, you're going to have 0.6 and 0.8. So in the x-axis, oh shit, wait. 0.8, this is 0.8. This is 0.6. So let's switch this back. 0.8, negative 0.6. Same thing over there. In point F, in the x-axis, going this way is positive, so you change it, become negative 0.8, and it's 0.6 positive. And the rest is 0. So, 1, 2, 3. Yeah, you do the same thing. You take this big matrix, take the inverse, and times B. You're going to get a list of. Should I write it? Alright. You're going to have this. This is for the real number. This is unit number, unit load.
These are each for the real one. 47, 40, and then negative 24. That represents A, B, B, C, C, D, A, F.
No. See this? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, wait.
You should have 12, right?
No, let me see. 4, 7. Oh, I missed this one. There's another one, 40.44. This and this are the same. Yeah, I missed one here. So you just put it back there. Yeah. So this column represents this.
Okay.
Yeah. And the new one, if you do that, you're gonna get. Let me see. You're gonna get 0, negative 0.8, 0, 0, 0, negative 0.8, negative 0.6, negative 0.6, 1, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah. So you have this. After you find this and this, I'm going to erase over here. After you find this and this, for the real number, it's going to be your delta. We remove FC, so it's going to be delta FC. And this one is going to be your FC, CF, something like that. So if you have this and this, you're going to have another table called this. Members, you're gonna have AB. Just copy everything from here. AB to BE. So you're gonna have AB, BC, CD, AF, BE, EF, FB, EC, BE. And you're gonna have a column called A, which is area, I, E, not I. A and E, big N, small n, and you're gonna have the last column, you're gonna have, that's enough space. You're gonna have big N times small n times L over AE. And the last one, let me erase this. Small n squared times L over AE. And the question tells you A and E is constant, so you don't need to worry about this, so just cross it out. For big N is your real numbers.
That's A, E, N, and D.
What?
Is that the letter D?
Where?
A, E, N, and that's
Small
the D.
n.
Oh, small n, okay.
Yeah, small n.
You write that
So for big N, you just copy everything and put it right here. So you're gonna have 756, 40.44, negative 24.44, negative 50.56, negative 19.55, 14.67, 25, 8.89. What the hell? Ah, I missed one again. $40.44, negative 24.44, negative 50.56, negative 19.55, 14.67, 25, 8.89. And for small n, it's your unit low numbers. So you're going to copy this and put it right here. So you're going to have 0, negative 0.8, 0, 0, 0, negative 0.8, negative 0.6, negative 0.6, and 1. Yes. So for this one, idiot. I mean,
you forgot L.
yeah. A and E. So you cross it out, and this one you're gonna make it our L column.
It's okay. You could have just taken out A and E. It's fine.
I mean, yeah. I just wanna let them know this AE over there. So 20 feet, 20, 20, 25, 25, 20, 15, 15, 25. So for this one, you're going to take the big N times small n times L over AE. So you take this times this times this. Since you have 0 here, you're going to have 0, negative 647.04, 0, 0, 0, 312.8, negative 132.03, negative 225, 222.25. And for this one, small n squared times L. So take the square root or take the square of this times the L. So you're gonna have 0, 12.8, 0, 0, 0, 12.8, 5.4, 5.4, 25. So you take the sum of this thing. For this column, it's going to be negative 469.02. And for this one, you're going to have 61.4 E8 over E8. So after you have this and this, this column is called delta FC. This column is called FC, CF. So you have this and this. Before, when we had this truss, we remove this one and we put one as this. So if you do that, you're going to have a formula called this. Delta FC plus force FC, I mean just call FC, the internal force of this member, times FFC CF equal to 0. Because it is there, if we remove it, this plus this should go back to 0 or original, so it's 0. So when we have this and this, because we find it already, F this, delta FC and delta and FCF and FC, so we can find our FC real numbers now. So you just take this, do it to another side, then divide it by this. So you take this number, negative number, do it to the positive side, so it's going to be positive 469.02, because this is this, this is this. Then divide by this, divided by that, divided by 61.4. Like I said, E8 and E8 can cancel, so that's why I didn't write it down. So this number is positive 77.64 kg. This number is positive. What does that mean? Before, we remove this and we put 1 here. If the number you get is positive, that means it is tension. But if you get this number is negative, that means the arrow is going to this direction, become compression. But since this is positive, that means this internal force is tension. So FC is tension. So now we have FC. So we have FC, so we can find the whole thing again for all the internal force and the reactions. So like I said before, this is not going to change. The big one is not going to change. All it changes is just this column. So you want to find the force. Can I erase this?
Okay, so that's a positive number, so that's a
Tension.
Right?
Yeah, let me erase this.
Should be compression, because that's one, you have a negative number, negative 469.2.
No. This is this number.
Okay.
You have to do it to this way. So
Got it.
become negative. Negative times negative become positive.
Got it.
So let me erase this. So right now, oh wait a minute, F, B, C, D, E, F. FC, we find it. Oh, we erase it. This number is 7.64. And before we're gonna have 20, 25, 28. Yeah, that's all the force we had before. So you're gonna use this and put it over there to find all the internal force. So how are you gonna do it? You do the same thing. At point A, at point B, you're gonna have point B, you're gonna have in the y-axis, you're gonna have 20, and that one's point C. In the y-axis, you're gonna have 25, point E. In the x-axis, you're gonna have negative 28, 0. After we find this, you have to convert this into the x and y component for point F and point C, like what we did before for the unit load. 1, so you're going to have 0.8, 0.6, 0.6, 0.8. Same thing as this one. You have to find the y component and x component. So if you do that, you're going to have 4.582, 6.112, same thing, 6.112, 4.582. So for this one, in point C, so because right now this force is all acting at point C, so at point C, in the x-axis, going that way is negative, so you're going to have positive 6.112. And in the y-axis, pointing up is positive, you have changed it back, so you're going to have negative. So 25 minus 4.582, 4.582. And for point F, in the x-axis, going this way is positive, so you're going to have negative 6.112. And in the y-axis, going down is negative, so you have to change it to positive. So 4.582. So and the rest is 0. Yes. So you do the same thing. You take this big matrix, get the inverse, times this. You're going to have a list of numbers. You're going to have 47.55, 34.33, 40.44, BC, AF, you're going to have negative 24.44, negative 50.56, DE, right? Yeah, DE. EF, you're going to have negative 25.67, FB and EC, okay. You're going to have 10.08, 20.42. You're going to have 16.53. EC, yes. And you're going to have negative 28. You're going to have 14.06, 30.67 and 30.33. So you have to put all the force back into the original one to get the full credit. So let's do it. Now erase this. So AB, you're gonna put it back. This is AB. Yeah, you just put it back. No problem, right? Because you have AB, you just follow this and just put all the force back to this one. And put all the reactions,
Got it.
right? Do you understand?
Yeah, got it.
Continue.
Now instead
No,
of,
I'm done. I'm not going to continue.
Oh, you're done?
Waste of time, yeah.
Wait, repeat.
So
repeat.
this, see, not listening.
I'm
See,
sorry.
this adding is the members. A, B,
Yeah,
BC.
Yeah.
So you just take this, for example, I'll just give you an example, 47. So this member is 47.55.
okay.
And the reaction for this one is 30.33. You just put adding back
and that's it.
into the truss. So that's it. You're done.
Okay, that's it. You just write the force of it.
I'm not going to erase this one because for Part B, you're going to use the same matrix.